Hello. Alright, today we're going to look at my code for my Sudoku solver. So we're going to start in game 1. I decided to use monogame so that I can have a physical sprite-based representation of what my puzzle looks like while it's solved. So here's where I instantiated everything. So in my initialize method, I start by creating a cluster of squares using my for loops and putting them in my two-dimensional array called square container. I also pass in positions so they can be placed properly when they're drawn as sprites. This right here is a string so that it's easier to switch between the puzzles that you have. And right here is the code to parse it. So we're running through each square in the array. We're having a value be parsed from our string, from our puzzle string, and then we're having it stored in a temporary location. After that, we delete the first entry in that string at index 0, and then we go through and we say the solution for that position, for the square at that position in our two-dimensional array is equal to the value that temp is, and if temp is not equal to 0, that square is set to solved, because a 0 value means that that space is null and hasn't been filled yet. After that, we run through the first time. We use our checkRCN method using our for loop, and we say that if it hasn't been solved, then we go through RCN, because we don't need to check squares that have already been solved. They'll just pass through. We don't need to waste that time. Down in update, we call the same thing again, so it continuously does that. Here's all the drawing logic. So here's RCN. It takes an int r and an int c for rows and columns. I have this for loop set up right here so that it emulates values 1 through 9, and I use that to compare and set equal to at different points in my square class. So right here we're saying that if the square rj, which is not the square we're looking at, is equal to I, which is the number we're emulating, then we can say that the one we are looking at RC, we take the one-dimensional Boolean array that I have set up, and then we say the value at I is set equal to false, because what it's going through is that if any of the squares that we're looking at along this row are a value, then that the square that we are currently looking at on the row column cannot be that value, so we're setting it to false. We do the same thing for columns over here. And then after that, we go through the nonnet logic. Now, this is a big, ugly chunk of code, but it does its job. It's basically the same thing 3 times. And so what I did was, I said, alright, well if I'm within the bounds of this row, so from 0 to 2, essentially, I'll start running the logic for columns. And then if I'm within this column, I'll know that if I'm within these two, I'll know that it's the very first nonnet in the puzzle. And it works so on and so forth. At the end of this, I call a method I have stored in Square, called solveSquare. We'll go look at that right now. So I set up these 2 temporary integer values, and then I use this block of code to add an increment to them based on the values stored in the one-dimensional Boolean array. And so at the end of that, I test true, and I say if true is equivalent to 1, that means there's only one value in our Boolean array that was true at the end of the check RCN, which means that that can be the only value that that square can be. So we take that and we set the current square that this block is running in to true, and we set its solution to I plus 1, where I is the solution we're generating. Our square class, I've mentioned it before, but we have a one-dimensional Boolean array, size 9, and that's to store Booleans to kind of flag our squares for values that we have, or that can't be in it. So if the value is true, that means that if the Boolean is set to true, that means that that number at that index can be had, or index plus 1 can be had in that square. And if it's set to false, that means it doesn't exist. One of the problems I had with my code was my drawing method, and it works fine most of the part, but I got really hung up on I had little squares that were supposed to draw for each square while it was being solved that are supposed to disappear while it's being solved. But it runs too fast to see, but it doesn't work anyway. The larger numbers do work. I couldn't figure out why it was doing that. I tried switching around my methods a lot, but let's see the code work. It's not pretty, but it solved it pretty well. Let's go check another one. This is a different puzzle. It's 260. The last one was 259. This one seems to work as well. I did not set up for second inference solving, so I actually have a medium puzzle loaded in. We'll take a look at that. You see that it didn't really solve any of the values. So even though we have let's see. For example, in the middle row, the third column, 5 only exists in one of those squares, or the possibility for 5 only exists once and then on that. But I never made the code to check to see if one value only existed in the non-nat. So I'd have to work on that. I can already think of a few ideas of how I do that. But so this is the project I have now, and it works well. And hope you enjoyed my presentation.